Okay, so in this presentation video, we're going to talk about basic data analysis, and really what this is getting at is basic statistical data analysis. Statistics are a very helpful analysis tool we can use to analyze data and draw conclusions. Also, it helps us to compare data sets, data set X versus data set Y, and statistics allow us to boil down large sets of data to one or two or three individual data statistical values that describe that data set. So we'll get into what that looks like in this presentation. We're going to be in the analysis phase, right? So just to reference this video and the broader problem-solving cycle we've been talking about, we're in the analysis phase. And when we talk about statistics, they help us, like I said, describe large data sets. They help us draw conclusions about the data. Without having to show all the data, we can boil it down to one or two numbers: mean, median, standard deviation, to describe what the data is in general, or on average, or those things of those nature. Also, though, it's important to understand that statistics can almost say whatever we want them to say. We can, depending on the perspective we take and how we analyze our data and the question we pose, we can get the solution or the result to kind of say what we want it to say. So we've got to be very careful with statistics and the assumptions we make when we're analyzing and generating and calculating our statistics, the assumptions we're making about the data we're using. Because if we're not clear, or if we're don't clarify those assumptions, the conclusions that the reader can draw or we can draw can really be erroneous, right? Or not be very powerful. So the first and most important part of statistics is the sample size. How many data points, right? So sample size being how many individual points of data or measurements or values do you have in your data set. Okay, an example could be how many different pieces of equipment did you measure? Okay, and you're measuring the cylinder pressure of a piece of equipment, and so you want to get an average cylinder pressure across 100 different pieces of equipment. Okay, and so you measure cylinder 1, cylinder 2, all the way up to 100, right? So you have a sample size of 100. Okay, it's important to describe how many measurements or samples that you got, because the concept is the larger the sample size, the more accurate your statistics will be. Also, you want your data, the data set or the subsample or sample that you get, to represent a normal subset of the larger population. So the cylinder example, we measured 100 cylinders on 100 different tractors. Well, that's only 100 tractors out of many, many more tractors produced by John Deere in a given year. So we can't measure all of them, but we can measure a subset or a sample of the larger population. But we want that normal to be, or that sample to be a normal subset. We don't want it to be, have outliers if we can help it. It may have outliers, but we want to try and get our measurements to be a normal subset of the larger population. That'll help our statistics be more accurate. Also, the way that we collect data is important, and describing the way we collect data is important. We can select data and measure data randomly, or we can intentionally select how we measure or which pieces of equipment we measure. So we could say we want to measure the first 100 tractors off the line. Okay, we are deciding we're going to do the first 100. Okay, versus we'll randomly select 100 tractors out of the first 100 days of production. Okay, so we're randomly going to roll a dice or generate a random number, and that's going to tell us what tractors to measure when. Okay, so random measurements, random data collection has less bias traditionally or theoretically. So the human has less of a chance of having a bias in the data if it's random. Okay, we don't always get a chance to have 100% random data collection though. So we may only be able to collect data from the first 10 days of production. Okay, we can't randomly select out of the first 100. Okay, and then maybe the plant manager says, oh, well, no, you can only collect data in the morning. Okay, so we're hemmed in, right, to the first 10 days and to the morning. So that's going to affect the randomness or the bias in our data. If you have bias, it's not wrong. We just need to be clear on what it is and how we went about collecting the data, because that helps us interpret the statistics that we calculate. So the statistics we're going to look at in this video are measures of central tendency, basically the typical or middle points in the data. We have 100 cylinder measurements, and what's on average or median or the middle number of that huge 100 pieces of data. Okay, and so some different statistics we're going to look at are going to be mean or average, median, and mode. Okay, so these two shouldn't be new to us. Average weight, median salary. Mode may be something we haven't talked about or heard recently, but we may have. But we'll just quickly go through how we calculate these, and then we'll finish up with when we would use which type of statistic. So mean is the sum of all the data points, all the x's, divided by the number of entries or samples. Okay, and of course sigma just means add up all the different x data points, n being your sample size. Okay, so all 100 x's, add them up, divided by 100 will give us our mean or average, and that is said x bar. Okay, that's pronounced x bar. Median is a little bit different. Okay, it's the middle value of a set of data when it's set in order. Okay, so it's important that to find the median, we have to order them. And there's two different situations. We could come to a situation where we have an even number of data points and an odd number of data points. If we have an even number, we just take the middle two data values, add them together, divide by 2, then our median is halfway in between, or 3.5. With an odd number, it's easier, right? You just pick the actual middle number, and that's your median. Okay, so even number of data, median is the average of the middle two data entries, or middle two data points. And then mode, the data entry that occurs the most often. Okay, so you may have a single mode, one number that occurs more than any other number. Okay, you may have more than one. You may have two values, 10 and 25, and they both occur 10 times in your data set, right? So you have two modes. Or you may have none. You may have a single value for every unique data value. In that case, there are 0 modes. So in this data set, the mode is 3, okay, because that occurs 3 times. In this data set, it's 3 and 6. And of course, in this data set, there's no value that occurs more than once, so there is no mode. So all three of these statistics are ways to calculate a middle point in the data. So if we have ages of a class and we calculate our mean, we calculate our median, and we calculate our mode, we have 23.8 for mean, 21.5 for median, and 20 for mode. Okay, and so we can look at these and see how these describe our data set. So on the bottom here we have a frequency distribution of our values of age. Okay, so how many times we had different values, different ages. And if we look at this, we have our mode, right, at 20 years, way on the left. We have our median at 21.5, fairly in the middle. And then we have our mean or average kind of off to the right at 23.8. We also have this outlier. Okay, if you notice, there was one person in the class that was 65 years old. That's a very extreme outlier. Okay, And so when we look at these different statistics, a mean accounts for all the data, okay, because we take all the data, all values, and divide them by how many values there are. But it's influenced heavily by outliers, right? So that age of 65 pushed the mean towards the outlier, right? It pushed it up towards the right of our data set. The median accounts for all the data, okay, because you order them all in order, but then you look at the one that's in the middle. It is not affected by the outlier, okay? It's closer to the middle of our data set here. It's closer to what looks to be the middle, okay? Then, of course, the mode may or may not exist, and it may not be biased by the commonly occurring data with outliers, okay? So these are the three different statistics we could use with the different things or causes or things that affect them, okay, in a data set. And in this situation, I would propose that the median is the best choice of showing the middle of the data. Because the outlier exists, it's not affected by the outlier. It does a better job of showing the middle or center of the data, okay, with the mode possibly not even existing or being pretty far to one end, and the mean being really heavily influenced by that outlier. So in this scenario, I would use the median as the choice statistic to describe this data set. Now, we will have to decide mean or median and possibly mode what we're going to do. So 9 times out of 10 when you have drastic outliers, you'll use the median, and that helps you guard against those outliers affecting your data. We're not going to remove outliers in this course. We're actually going to decide to use the median instead of the mean. And so we're going to keep all our data in the data set, but decide which type of statistic to show based on there being outliers or not. And so this is just a kind of conclusion of what we've been just talking about in a table form. We have our statistics along the left. Account for all data in the data set. Yes, yes, no. Okay. Affected by outliers. Again, means are definitely affected by outliers, with medians not being affected. Okay. And of course, these median and mode are not related to the mean, which why would they be? But when we get down to the next video, we're going to see why we have this column. But these statistics, are they valid for blank distribution data sets? So are they valid for a normal? Okay, so a mean you want to use when you have a normally distributed data set. Whereas when you have a skewed data set, you want to use median or mode. And so what do I mean by skewed or normal? Think of a normal bell curve. Okay, you cut it in half, it's a mirror image of itself. Okay, half of the data is on the left side, the other half is on the right side. Almost identical. You could almost mirror that. A skewed data set could be something that has a bunch on one side and it has a very, long skewed tail. Okay, and so it's tough to, where would you cut in half to make it a mirror? It's not really a mirror of itself. It's asymmetric. Okay, so that's a skewed data set. You have an outlier or outliers way out here that skew that distribution. Okay, so these are the scenarios and the situations that we would use a mean or median or mode, the things that affect it, and the types of distributions that we would want to use the different statistics for. Okay, so that's why being able to plot a histogram, okay, graph a histogram of our data might be a really important first step to see the distribution. Then we can decide do we need to use a mean or a median. Now, we're going to jump over to Excel. We're going to look at the functions, the basic statistical functions to calculate these different statistics, okay, mean, median, and mode. And so I have an example file here, again, which you'll have on Blackboard. And in this data set, we have column A being our different samples, okay, so we have 500 samples, okay, of a black, a green, and a yellow. color sensor. Okay, and these represent the voltage level that was on each of these sensors for each of these colors. Okay, so when the sensor saw black, it had that voltage. When it saw green, it had that voltage. When it saw yellow, it had that voltage. Okay, so black's a low voltage, green's a medium voltage, and yellow's a high voltage. Okay, so if we want to find the mean or average of all the black, okay, so on average, what's the voltage? We measured 500 measurements. On average, right, what is that black voltage going to be? If you remember back to error, this will take away random error, okay? Taking an average across multiple measurements will remove some of the random error that we have that's inherent in our measurement system, okay? I can hit equals, okay, average, and then I can click the first one, and I want to select all of them, okay? So I can either click and drag, or I can click the first one, scroll down, hit my shift key, so with the shift key depressed, select the last one, and that has now selected all 500 black data values. And close the parenthesis and hit enter, okay? So that now, 0.4073 is my average of all the black samples, okay? So on average, there's a 0.4075 voltage that's outputted on the sensor when it sees black. Okay, so of course over here just a reference to the function we're doing. For the median, okay, how do I calculate the median? Well, I can do same thing, equals median, or if I forget, I can come up to my tell me what you want to do, and I can say median, spelled correctly, and I can, statistics, and I can come into, look for M for median right there. Okay, so now it gives me a little wizard window. I can say, what's my first number? What's my second number? Now, here we have to, again, select the entire range of data. So we would come over here, we would select the first one, and we would scroll down, hold our shift button, and select the last one, and hit OK. And so there we have a median of 0.4071. Okay, so very close, okay, but different. For the mode, now the mode is a little different. We can come in here, and I'll show you yet another ability to do this. We can also click on formulas. We can click on insert function, and we can say mode. And this is just a search window to help us search through different functions. Just a different way to find this function. And we're going to look at multiple because we want to make sure if there's multiple modes, we identify that. And so we look at the first value, scroll down, shift, second value, and we hit OK. And we have 0.4083 as our mode. Okay, so we've now calculated the mean of the blacks, the medians of the blacks, and the modes of the blacks. Okay, and one thing that's helpful about Excel, this is why we use Excel. One of the reasons we use Excel is we set up a calculation once, and then we can repeat that calculation multiple times. So if I select all of these cells, so they're highlighted, and I go down to this little green square until I get to that black crosshair. Click, and I can drag this across to the green and to the yellow. And what that does is it copies this function to the green as well as to the yellow. And Excel is smart. It sees that I'm moving over a column, so it looks at a column to the right of where I was before. Okay, same for the yellow. Okay, so it understands that I want to calculate the same function just one column over. Okay, and so of course I have to make sure that I want the next one to be green and the next one to be yellow. It just does it based on how many columns I've moved over. Okay, so I've now calculated the mean, median, and mode for all three of these. Okay, one thing that's also interesting, if you have a mean and a median that are identical or very close, that means you have a fairly normally distributed data set. So the closer the mean is to the median in value, the more normal the data set is. If those are very far apart, then you can tell that it's skewed in one way or the other. But if it's if those values are close, then you probably have a fairly normal distribution. And we can check that. We can say, let's select all of column black, okay? And we can go insert, we'll scroll up to the top here, insert, and we'll go to histogram, okay? So we can actually insert a histogram of that data, okay? And if we look at that data, it's fairly bell-shaped. This here is a little bit skewed a little bit, but if we go to maybe, let's say we had 10, that's looking like a better bell curve, right? And we talked about 5 to 10 being good, maybe 7 or 8. You might want to show closer to 10, but you can see that it's going to affect the actual distribution, and we're not going to talk about when to do more or less. We're just going to rule of thumb between 5 to 10, okay? We'll pick 7. That has a nice bell curve to it. And you could tell that, you could assume that, right, based on the mean and the median being so close, okay? So that's how we can calculate mean, median, and mode, and then we can do a quick histogram, right, to see that distribution of the data. And of course, that's only for the black. We could copy this for the green and yellow as well for other charts. Okay, so mean, median, and mode, understand the difference between them. Understand, though, that they're all statistics to measure the middle of our data set. We just need to understand and have a way to pick between the different statistics that we're going to show, okay? And depending on if there's outliers, this is the big key, right, to which one we pick. And the outliers affect how normally distributed our data set is. All right, I'll see you in class.